Greetings judges. Today our team Hodgepodge is present here to present our proposed solution Chat.e that solves existing problems that we have identified through thorough research.
In today's fast-paced world, e-commerce and healthcare often rely heavily on chatbots to assist their users. But these chatbots fall short when real people approach them with real problems. They struggle to detect emotions like frustration, confusion, or urgency. They can't handle complex user intent, like when a customer is asking for a refund but at the same time wants to track their order, or a patient is describing the symptoms while they are mentioning the medications that they're on. And worst of all, that these bots forget. They don't remember the previous interactions, which means users are stuck repeating themselves. The result: frustrated users, overwhelmed human agents, and an overall experience that is far from seamless.
So, given the problem statement, how can we fix today's broken chatbots? So, imagine a chatbot that actually listens, understands your emotions, and reacts to complex queries, and also saves your preferences based on your last conversations. Introducing a custom NLP system smartly integrated with a powerful chatbot framework that, at its core, is not only designed to understand the user and react to keywords. It analyzes sentiment instantly as positive, negative, or neutral. So it can adapt to prioritize urgent cases or escalate with empathy. Yes, a chatbot that can classify complex intents with over 90% accuracy, ensuring users get the help they need. And it keeps track of the user's conversation, so you don't have to repeat yourself over and over. Every response is informed by what the chatbot already knows about you, and so every conversation carries a personal touch.
As we have already discussed the proposed solution, let's dive into how our team approaches the problem and practically implement it. Let's explore the technicalities first that we have included in our project. For the front-end part, that is user interface, we have included Next.js plus Tailwind CSS plus Axios. For the backend part, we are using Fast API. And for the libraries, for vector retrieval, we are using FAISS, and for the data validation, we are using a Python library which is Pydantic. For the vector embeddings, we are using Hugging Face APIs. For the transformer, we are using a popularly known transformer which is BERT, which is fine-tuned for intent classification. For the framework, we are using LangChain. And for the LLM interaction, we are using OpenAI GPT 3.5 or 4. And as far as database layer is concerned, we are using SQLite. Let's explore the front-end part first. Users chat through a clean UI built with Next.js plus Tailwind CSS. Messages are sent instantly to the backend part via REST API. Once the message reaches our backend Fast API server, here is what happens. Firstly, input validation occurs using Pydantic, which is a Python library. Second, sentiment analysis occurs using Hugging Face transformer, which detects user emotion, if he or she is feeling anxious, stressed, or calm. Third, for intent classification, we use another fine-tuned model, which is BERT from Hugging Face. Next is context retrieval, which is we are going to use to fetch recent chat history of a user if he or she has some recent medical diagnosis, which is going to help in the future. Next is embedding generation, in which we are going to use Hugging Face sentence transformer. Last is FAISS, which is used for vector similarity search. Next is prompt assembly plus LLM response. We assemble the prompt using LangChain. That prompt is sent to GPT 3.5 or 4 to generate a personalized and helpful response based on user interaction with the R chat. For the last part, which is our database or session archival, we are going to save user input, its intent or the response generated from our chatbot. We are also going to save its tracks, which includes session ID, timestamp, and at the end, we save session context snapshot for future convos. As we have already discussed, system architecture. The diagram here shows the data flow for a single user session.
So, moving on to innovation and uniqueness, we have an animated demonstration film.
In today's digital world, chatbots have become a common way for businesses to communicate with customers. They're fast, available 24/7, and, well, sometimes helpful. But are they truly understanding us? Meet Ritu, a concerned patient of XYZ PVT Limited. She's not feeling well and wants to ask a few urgent questions. So, Ritu does what most people would do. She reaches out to XYZ's chatbot. Yes, the one built using classical methods. But instead of help, she's left more confused and frustrated. Wait up, what just happened here? Well, Ritu just went through what most users despise about traditional chatbots, that is, they often lack three key abilities: emotional understanding, context memory of previous conversations, and intent recognition. Now, imagine if XYZ Private Limited had used Chat.e as their chatbot integration, or, wait, the conversation went very well this time and it was as if the agent remembered past interactions with Ritu. Chat.e not only responds, it understands. It's simply just an intelligent NLU-powered chatbot that detects emotions in real time, understands complex queries, and remembers the context, because we believe
Because every form of interaction matters and conversations deserve more than just automation and a cold hard system.
So, building such a custom NLU-powered chatbot is game-changing, but it's not without challenges. Here, we have the 5 major challenges that we faced. First is accurate intent classification. It's hard to know and classify what the user actually wants. So the fix is to train advanced models like BERT on real-time data and a large number of user database. Next up is context management. It's not enough to just analyze the emotions and the sentiment of the user. We also have to learn and respond in accordance to the previous context and the data that we have stored about the user. Next up is real-time sentiment analysis. Such a sentiment analysis is a huge and time-consuming and resource-consuming task, which comes at a heavy CPU cost. So we used open lightweight models like OpenAI 3.5 or 4.0 models to achieve this. Lastly, we have training data and domain analysis. Again, this type of NLU will basically benefit a lot if it is trained on specific domains and specific amount and large amount of training data.
But this is just the beginning. The future of this chatbot system lies in becoming a truly intelligent industry-agnostic solution, capable of transforming how we interact with technology. With advanced multi-modal capabilities, it could go beyond text analysis, voice tone, facial expression, video calls, and even images. It could dynamically adjust its responses based on the user's age, background, or communication style, creating a truly personalized experience. This can automate the customer care portion of the industry to the max extent and reserve the human task force for important actions that need manual supervision. Real-time databases, it could deliver the latest product updates, medical guidelines, and policy changes without needing manual reprogramming. Multi-language support and cultural adaptability would make it globally accessible.
Thank you for your time. We hope you liked it.